So I really liked the effect that the ribbon embroidery and the normal embroidery gave on the sample pieces I've done. I wanted to look at ways of keeping it in with my sustainability theme. So I looked at different ways of producing dyed silk, but I also looked at silk as a material itself. In normal silk production, silkworms spin their cocoon, and they then normally will be steamed before they break out of the cocoon to keep that entire silk thread intact, therefore killing the worm in the process. Piece silk, on the other hand, allows the silkworm to complete its life cycle naturally, breaks through cocoon, and they go on and live a happy life and do what they need to do, and then the threads are then used after that. The other problem that I came across was that many of the embroidery threads and the silk ribbons were dyed using man-made dyes, or dyes that would produce quite harmful chemicals that then would go into the environment. So with that in mind, I'm looking at dyeing some piece silk embroidery thread, and I'm going to make this into strips to make my own silk ribbon. So this is piece silk. It's been farmed naturally. So the animals haven't been harmed in the process. Natural dyes wise, I've got 10 different dyes. I've got varying colours ranging from lac. I've got lac, coreopsis, weld, woad, logwood, Brazil wood, Quevacho red, madder, cochineal, and logwood oxidised. So these should give me quite a good colour range. With natural dyes, you can alter the colour. So depending on whether you use an acid water base or an alkali water base, a neutral water base, you can achieve different colour results. And afterwards as well, you can also put them through an afterbath of either copper or iron to give them a slight colour variation. These are known as colour modifiers. So with the embroidery threads, I plan to do the entire colour variation. I've got 10 different dyes, and each one of those dyes will produce me 5 different colour variations. With the ribbons, due to the cost of the silk, I'm just going to dye the main colours of the ribbons to see what sort of effect it gives on the ribbons. So I've already encountered my first problem. The silk has been provided on skin for me, and untangling it into its individual pieces for dyeing is proven to be a problem. I intended to separate it into, so there's 1,000 yards in total. I intended to separate it into 10 yards each, because it was a nice divisible number, and do individual dyes. In hindsight, I should have bought a cone, which would have been much easier to separate out into the individual strands, but I am currently stuck with this. I think if this works, if it's successful, if I can get the colours out of it that look good, and I take it forward to my FMP, I think I'll probably purchase a cone purely for timescale purposes. It will speed up the production certainly a lot quicker, and make my life a lot easier. So the normal process for dyeing with a protein-based fibre, which effectively is an animal fibre, is to mordant it first. So you use something called alum, which allows the fibres of the fabric that you're dyeing to open up, take the dye properly to become colour fast later on. The problem I have with silk is it can be really affected by high heat. So normally you would mordant at quite a high heat for a short period of time. But with silk, if you do that, it's going to lose that inherent shine and the suppleness about it. So what I'm going to do instead is I'm going to mordant the fabric in alum, but I'm going to mordant it at a lower temperature overnight and leave that until the morning, and then mordant it, and then it'll be ready for dyeing the next day. With regards to the alum, there is no set weight that you should use. You base the quantities on your weight of fabric. So you weigh your dry weight of fabric, which will give you a figure to work with, and you can range from anything from 10 to 20% of alum with silk for dyeing purposes to allow it to dye properly. So I'm going to work with 15% and see how we get on and see what results we get. So first protocol is to weigh our dry wet fabric. So I have I've separated them all out into their individual 10-yard pieces. And as an average weight, we're looking at around about, it varies from skin to skin. It varies from about 82 up to 85 grams. So I'm going to use 85.85 grams as my dry wet fabric for this one. And for the ribbons, they are around about 2.2 grams per ribbon. So I've got 10 ribbons. So calculations as follows. If I've got 50 strands at a 0.85 each, that totals 42.5 grams. 2.2 grams per ribbons, 10 ribbons makes 22 grams. So a total weight of 64.5 grams. So my WAF weight of fabric is 64.5 grams. So 15% of that works out at 9.7 grams. So I will soak the fibers in 9.7 grams of alum mixed with water overnight, ready for dyeing. See, now I'm going to use deionized water. Our water here is we run off a natural spring. We have incredibly hard water and it's got a lot of minerals in. We've had it tested and it's got iron, magnesium, all sorts in. So I don't want that to affect any possible outcomes. So I'm trying to negate those effects. So I'm going to use deionized water that has no minerals in and is a nice even pH level. And then from there, I can alter the pH level of the waters to make an acid and an alkali water at later stage. But certainly for Mordanton, I'm just using deionized, nice neutral pH water. So prior to Mordanton, you should scour any fabric. Normally you would do this in soda ash, and hot water, but because again, silk is very delicate, I don't want to add too much heat to this. And actually it shouldn't, the scouring process is designed to remove any chemicals. There shouldn't be any chemicals because this is naturally produced and it's piece silk. So all I've done is I've rinsed off in a mild detergent and leaving it to soak. So I've left it to soak for 2 hours prior to Mordanton. It allows the fibres to open up to really absorb in that mordant to allow it to take the dye properly. Okay, so my fabrics have been Mordanton overnight, so now I'm going to dye my fabrics. So what I was going to do is I bought veg bread cups because they're sustainable, and I was going to measure out the dye individually per cup. However, bit of a problem in that my scales won't measure down that small. So if each skin is 0.85 grams, I am going to use as a starting point 10% weight of the dry fabric to the dye to make my dye solution. That works out at 0.085 grams, which my scales will not measure down that small. So instead, I counteract this problem. What I'm going to do is I'm going to make the dye for each colour. So there'll be 5 different batches. I'm going to make it in one lot and then divide it between 5 cups. Then alter the pH of the 2 that I want to alter the pH for and leave the other 3 at neutral pH. Leave 1 to dye in its neutral pH and the other 2 will be used with an afterbath afterwards. So that is where we are at the moment. So I've got my dye pots ready. I have all the colours weighed out, so 10% to the dry wet fabric. So the dry wet fabric for the 5 skins I'm putting across the 5 cups is 4.25 grams. So I've used 0.425 grams of each of the dyes, which are ready to mix up. So I'm going to, there's 3 pots going to be used with a neutral pH water, and then 2 of them, one is going to be a high pH, one is going to be a low pH, to see what effect that has on the colour of the dye. At the moment, I don't know what quantity of water I'm going to use, what quantity of substance I'm going to use to alter the pH, but I'm using sodium carbonate and citric acid to raise one and lower one. I'm aiming for a pH levels round about I'm going to take it down to a pH level around about 4 or 3, and then raise it up to 9 or 10. So I'm going to do a quick trial run with deionized water. I've got a pH reader, and go from there really. That will allow me to work out what quantities I need. I imagine it's going to be a pinch of each to raise and lower, because we're working with such small quantities of water. So I've just boiled some distilled water. I'm going to measure out 200 ml of it, test the pH level, see if we can lower it. The pH level of this is 7 point. Say 7.6, which is most neutral. So if we first of all add a pinch of sodium carbonate. I have to use hot water because it needs to dissolve. But obviously with silk we can't keep it at a really high temperature for a really long time. So I'm going to have to work quickly with this because the dye will need to dissolve in the hot water as well. Just wait for that to dissolve in. So that was a pinch of sodium carbonate. Let's remeasure. Yeah, so a pinch has taken it up to 10.6. So if we test to see if we can get it a bit higher, another pinch. Dissolve that in. And the pH reading actually hasn't taken any higher. Another pinch of sodium carbonate. Let's see if we can get it higher again, maybe up to 11 or 12. Let's see what it does. No, so it won't go any higher than 10.7. So a pinch will raise 200 ml of water. So let's see if we can lower it. Lost me some water. I'll measure out another 200 ml of water, because that's what we will be using in the cups. And this time we will use citric acid, so we can lower the pH. So let's measure it to start with. It takes a while to settle because of the previous reading. This one should come down to about 7 as well, because it's exactly the same water. Stir. It's dropping down now. Weirdly, that's measuring a higher pH to start with of 8.2, even though it's exactly the same pan of water. Okay, let's try 2 pinches of citric acid. Let's dissolve that in. That's lowered it. Yeah, that 2 pinches has lowered it massively. Let's just test the water in the pan, just for curiosity's sake. So this is distilled water. It should have a neutral pH. Yeah, 7.5. Let's test the citric acid one again, just to be on the safe side. Yeah, that's really low pH. Based on each cup, we'll want 2 pinches of each to lower and raise the pH, but we will test each one as we go. Actually, we won't be able to test each one as we go because the dye will transfer onto the pH reader. Okay, so we're going to be working with pHs of about 1.5 and 11, based on 2 pinches to 200 ml of water. Right, so I'm ready to start the dyeing process. I am going to, first of all, take my mordanted fabric and rinse them in distilled water, ready to go straight into the dye pot. I have to work quite quickly with this because whilst silk doesn't do well with heat, it still needs to be hot to allow the dye to actually absorb into the fibres. So I want all the fibres ready to go into the varying dye pots as soon as it's ready, so it will still be warm. So I'm going to take out 5 of these. 1, 2, 3, 4, 5. 1 ribbon. One thing I have noticed about this ribbon is that it is fraying quite badly. So we'll have to wait and see once it's actually dyed to see how badly it is fraying overall, to see whether it could even be used for ribbon embroidery. My instinct is telling me it's probably not going to be suitable, but once it's ironed we could probably tie up the fraying sides on it. So squeeze it out. Let's see, it's tangled again. So I've got my distilled water boiling on hob. Get some hot water. And we'll just leave them in there to rinse. I'm going to take my pre-weighed dye with a little bit of the distilled water that's quite warm, nearly boiling point. I'm going to mix it into a paste. This is just that it will make it easier to dissolve into the water. Need a spoon. So some of these powdered dyes dissolve easier than others. Some take a little bit more work to dissolve down. Now, we're currently using Weld at the moment. Which is going a little sludgy in places. The water needs to be hot to allow the citric acid and sodium carbonate to dissolve in it properly. If you try and add it to cold water, it doesn't dissolve, so we won't get the pH change that we need. So I'm going to just, before we do anything, measure out 200 ml and mark a line on one of my cups so I know roughly what 200 ml is. So the water isn't too much of a, you don't have to be too accurate with the water, as long as the fibres have got enough to swirl around in. They'll be fine. So let's just measure out 200 mils in one of the cups. So we are going to just above the Vetware logo on there. Okay. Just gives me a rough estimation to work with. And I can work quicker without having to without having to measure it out super accurately. So there's going to be 200 ml roughly in each cup, so I'm going to need a litre across to split between them of the dye solution. So we're going to mix up the dye solution first. Litre of water. Add the dye to it. So as I said before, we were using 10% of dye to the dry weight of fabric for this as a starting point. I think the more dye you use, the stronger effect you'll get. If we quick. I have a jug that leaks, excellent. Pour that in there. First problem. Hot water melts the cups. That's going to be an issue, seeing as I have 50 of these to use. Okay. Let's balance that now. Right, let's leave it to cool for a little bit. Let's tidy up all the stuff I chucked everywhere. Okay, so I think to start with I'm going to need a better jug. One that doesn't go everywhere. And pour the dye everywhere. And the heat is having an effect on the cups. Let's try another one. You can see it's definitely melting. Okay, so these cups will not handle heat. Right, so it's not going to be, the heat isn't going to be, let's think about this, heat isn't going to be an issue for those ones because they're going to be neutral, so they're all exactly the same solution. So effectively this solution will be going to these 3 cups. It's the pH changing ones, so it's the high pH and the low H cups that I need to withstand more heat. So seeing as I've got this mixed up, I do have a couple of spare pots and things lying around. So let's transfer that into there. That into there. Okay, right, so from there we will change the pH levels of these now. Leave that to cool before putting it in the neutral pots. Right, so let's pop that one to the side. Right, so we said pinch of each to start with, rising 2 if we needed it. So let's give that a stir in, leave that to dissolve. Measure pH. I should have measured the pH before I started, so let's measure it on the neutral one, see what reading we're getting. So this one is coming up at 6.3. Let's just rinse that off in some distilled water. Off. So interestingly, the distilled water is measuring 7.6, so even by adding the weld it's reducing the pH level already. Right, so we've put sodium carbonate in this one, and this is taking the pH to, let's wedge it inside and let it settle, 10.6. So I originally said between 9 and 11, so if we can get it up to 11, that would be good. So let's add a little more sodium carbonate, give it a stir. Obviously the higher the pH, the more colour modifier it will do, if it's going to do anything. Right, 10.7, this is now 4 pinches. And then rinse off. Anything, it's actually made the dye a bit clearer. So the original one, the original dye water is quite cloudy. Sodium carbonate has almost made this a much clearer solution. So 10.8, 10.9, 10.9. So this is 10.9. Let's rinse that off again. See if we can get that back down to a neutral figure. Falling over. Right, so I'm going to add citric acid to this one. Now this reduced it quite rapidly, quite quickly. So we'll start with 1 pinch. Dissolve it in. So my intention is to leave these dye pots overnight to really allow the dye to get in, especially now. I was only going to leave them for a few hours, but because I'm now going to have to do them as cold dyes, I think they're going to need longer in the pot, so I'm going to leave them overnight. So that was 1 pinch to the citric acid. Yeah, that's taken that down to 1.5 almost instantly. Okay. So those two are ready to go. This will be, I say, one pH of 1.5. Okay. Rinse that off. One side. So I'm going to have to leave this solution to cool to go down, so it will go in the vegware cups. Wasn't expecting them to melt under heat. The other option I have is to order in a different set of cups, maybe some of the paper coffee cups, the disposable ones that can be recycled. That might be an option. I will look into the specifications of these cups to see what temperature they can take before I make a decision on that. Okay, so I've had a look at the specification for these vegware cups. They will only take up to 40 degrees heat, which well, it says on the bottom from -10 to +40, which is just over room temperature, sort of bath temperature. I think the heat is needed to get the dye into the fibres. So I am going to, certainly for this, because this batch is already mixed, for this batch I'm gonna use something else for these ones and go and hunt down some other options to dye these in. So I've got some spare pots lying around for these ones. You can already see that the dye, the changes in the dye colour. So this is the neutral one, this is the pH raised, this is the pH low. So the pH lowered already looks very pale. This looks really sort of goldeny, very warm yellow, almost sunshiny yellow, buttercup yellow, whereas this one's a really sort of like pale yellow. It's got a lot less orange in it. So we're going to give this a try with some spare pots I have lying around, because I want to get the heat into it rather than leave it. So I'm just going to divide this. So as long as the fibres have got enough fluid to move around in, we should be okay. So this is still quite warm at the moment, but not hot enough that it's going to damage the silk. So silk will take up to about 85 degrees Celsius. After that, it will start to damage it and it will lose its sort of luster and shine and suppleness. So we've got the pre-made skeins here, and we'll just pop them in. They've been rinsed in a neutral pH again, pH water. So I've got 3 of the neutral bases. 2 of them will be, after they've been dyed overnight, will be put in an after bath. One of them is a ferrous sulfate. I'll make a ferrous sulfate solution, which is iron, and the other one is a copper sulfate solution. So they will literally just be dunked in, pulled back out, because I think the colour change it will impart on it is quite quick, so I can re-dunk if I need to get different colour variations and darker shades and so on and so forth. Right, I've got 1 in each of the pots, and I'm going to add the ribbon into one of the neutral ones as well. Now we'll add it into this one. Make sure it's got enough room to move around. A little stir. So these will be left overnight. In the meantime, I am going to go and track down some different, more suitable pots for dyeing. So I had a bit of a disaster yesterday with the vegware cups. So I went on the hunt for something that I could use instead of the vegware cups that would sustain, would be okay with heat. After a 3-hour round trip and 4 different shops, I managed to find some cups that can be recycled, that will keep in with my sustainability theme. Finding these in lockdown was not easy. Then after that 3-hour round trip, got home only half an hour later when I was going to start dyeing again, to find my husband decided to dig through our mains electric cable. So we've had no electricity all night, which meant I haven't been able to do dyeing. So following day we're here, and the weld colours have been left overnight. So I'm going to go ahead and dye all the others, leave them overnight. It does mean that the weld is going to be left for more than overnight. It's going to be closer to 24 hours by the time it's rinsed out. I don't think it's going to have any effect. I think if anything, it will just mean that the colour will be a bit stronger on it. So we will get on and get that done. So all the dye pots are sat ready to dye overnight. So at the back we've got the cochineal. So the thing that concerns me about the cochineal is if you look at the one where I've raised the pH, it's got a really dark colour, and the one's got a really light colour. And up this end where I put the silk in, this is also got a dark colour. I'm wondering whether the silk's had an effect, because if you look at the pots that have got the extra silk in, they've all gone a slightly different colour, and I'm wondering whether the natural silk, as in the silk ribbons I'm doing, is altering the pH level of the solution. So this one, lac here, that's got the silk ribbon in, has gone a lot darker than the one that's meant to be neutral. So I'm wondering whether the silk ribbon has a slightly different acidity level and is altering the pH. So we're going to leave these overnight, and then we will rinse them out tomorrow. Give them their afterbath. So these ones in a copper afterbath and a iron afterbath, and see what colours we come up with. Okay, so following day, all the dye has been left overnight. I had to actually end up using the vegware cups because some of the paper cups started to leak. So actually they came in quite handy. So we're at the point now of rinsing and doing the afterbath. So I'm going to do one ferrous sulfate afterbath and one copper sulfate on afterbath on the two neutral ones that I left. I've worked out quantities, so based on the weight of fabric, I'm doing the iron sulfate at 1 to 2% weight of fabric, so that's between 0.085 grams and 0.17 grams of ferrous sulfate, added to a hot water solution, which I'll then divide out between 10 individual pots to dip the neutral dyes into, neutral dyed fabric into. With the copper sulfate, I'm doing that at 5% of dry wet fabric, so that works out at 0.4 grams. That's weighed out and ready to go. The thing that concerns me with these is yesterday I noticed that some of them had changed colour with the silk ribbons added. So, for example, this one here, which is lac. So these all three are all neutral, meant to be neutral solutions. And there is a remarkable colour difference between them. So if you look at the colour of this one, it's quite pink in colour. And then you go to the other neutral solution and it's much, ooh, I can't get it out. It's much redder in colour already. So I think the silk ribbons have actually changed the alkalinity of the original neutral solution. So what I'm going to do is, before I dip into the copper bath or the ferrous bath, I'm going to take a sample off of these ones before I dip them, so I have something to compare to with this one. It's not the same across all of the dyes. Some of them are very similar in colour. So the madder doesn't look to have changed too much by adding the silk ribbon, but a lot of them have. So the Quebracho red looks very different shades of colour, but even though they're both meant to be neutral. So we'll get that underway.